inverse functions. We have the line y equals x. Here is our function, which starts here and ends here. So the domain, so along the x-axis, x can be more than or equal to 1, but less than or equal to 4. And the range along the y-axis, y has to be more than or equal to minus 2, and less than or equal to 2. Here are 3 points on our function. The inverse function will be a reflection of our function in the line y equals x. So any graph reflected in the line y equals x will give an inverse. Only one-to-one functions, those that pass the horizontal line test, have a one-to-one relationship and have an inverse. And here are the same points after the reflection. And what you can see here is the x and the y values have swapped around. X and y, they've swapped around. 4, 2 becomes 2, 4. So the key thing to remember is for inverse functions, swap x and y. This is the notation for an inverse function. So this is for a function, and this is for the inverse function. If you look at the domain for the inverse function, so that's from minus 2 to plus 2, and the range, which is between 1 and 4, like so, you can see that the domain and the range here swap over. So in the domain we've got between 1 and 4, and that now becomes the range for the inverse between 1 and 4. The range here between minus 2 and plus 2 becomes the domain here between minus 2 and plus 2. But remember, the domain is always in terms of x, and the range is always in terms of y. So to get an inverse function, we must start with a one-to-one function. We reflect the graph in the line y equals x, so we're swapping x and y around, we're swapping the domain and range, and then we get the inverse function. So starting with this function, with a restricted domain, if you put 4 into here, 2 times 4 is 8, plus 1 is 9, that's where that 9 is coming from. The 4 is just what's given in the question, that's all, that's where the 4 came from. So, y equals 2x plus 1, swap the x and y around, so change the y into x and the x into y, and then rearrange this to make y the subject, like so. So we can write this using function notation, so the inverse function is x minus 1 over 2, and the new domain and range, so for this inverse function, we need to swap these two around. So the domain is now more than or equal to 9, x more than or equal to 9, and the range y more than or equal to 4. Example 2, our function, domain, range. That minus 13 comes from putting the 3 into here. This is the graph for y equals 2 minus 5x, but we have a restricted domain here. X is greater than 3, so only this part of the graph counts. When x is equal to 3, then 2 minus 5 times 3, so 2 minus 15 will give minus 13. Because x is greater than 3 but not greater than or equal to 3, then y values are less than minus 13. So to get the inverse function, swap the x and y around, rearrange to make y the subject, then use function notation and write down the new domain and range by swapping over the domain and range here. Example 3, x is equal to 10 goes into function f. Whatever comes out from function f goes into the inverse function. If you have a function and its inverse, one after the other, they undo each other. So the input and the output will be exactly the same. So if 10 goes into the function and then whatever comes out from there goes into the inverse function, what comes out from the inverse function will be 10, the same value that initially went in. Example 4, t is going into the function. Whatever comes out of the function goes into the inverse function. Again, you've got a function and its inverse, one after the other, so they undo each other. So what goes in is what comes out, t. Example 5, clearly this is not a one-to-one function, so it has no inverse. At the moment, x in the domain can take any value. So we can restrict the domain. So the domain has now been restricted to x greater than or equal to 2. And something like this will be just given. There's no reason why 2 was selected in this case. It was in the question. So that's a restricted domain. So y is more than or equal to 4. This is now a one-to-one function, so it has an inverse. So we're going to swap the x and y over, and then make y the subject. But we've got a choice here. Is it the positive or negative square root? And it's only one of them. We can decide which one it is by looking at the domain and range of the inverse function. Looking at the domain here, x greater than or equal to 4, if you put any value greater than or equal to 4 inside the third, to get this range, this needs to be plus. You cannot have a minus here to get this range. Example 6, quadratic function, complete the square. It's very useful. The domain, it's a restricted domain, giving this range. Let's work out the inverse, swap the x and y, rearrange to make y the subject, so take the 2 to the other side and then square root. Again, there's a choice. Looking at the domain and range, for the range to be y greater than or equal to 3, then the sign here should be a plus. Example 7, the domain, the range. So to work out the inverse, swap the x and y over, rearrange to make y the subject, and what you end up with is the same. The inverse function here is the same as the original function. This is called a self-inverse function.